Ever wondered why pi is such a big deal in mathematics? It's a question that's been asked by countless students over the years, and the answer is as fascinating as it is complex. In its simplest form, pi is a mathematical constant that represents the ratio of a circle's circumference to its diameter. But delve a little deeper, and you'll discover that pi holds a world of intrigue. Pi, denoted by the Greek letter pi, is a symbol that's known and recognized worldwide. It's as universal as the language of mathematics itself, but what makes pi truly unique is its nature as an irrational number. For those of you new to the term, an irrational number is one that can't be expressed as a simple fraction. It's a number that continues indefinitely without repetition or pattern, and pi is one of the most famous examples. When you try to express pi as a decimal, the digits stretch on like an endless road, with no sign of a repeating pattern in sight. As of now, pi has been calculated to over 31 trillion decimal places, and yet, we're still no closer to finding an end. This endless, patternless nature is what gives pi its mysterious allure. It's a number that's both infinitely complex and infinitely simple, all at once. But pi isn't just a mathematical curiosity, it's also a mathematical necessity. Without pi, we wouldn't be able to calculate areas of circles, volumes of cylinders, or the trajectories of planets. It's a number that underpins so much of our understanding of the natural world. So what's the big deal about pi? It's more than just a number, it's an enigma, a mystery that mathematicians have been trying to unravel for thousands of years. It's a symbol that represents the infinite complexity of the universe. It's an irrational number that defies our human instinct for pattern and repetition. So pi is more than just a number, it's a mathematical constant that holds a lot of intrigue and importance. Now, you might be wondering, what is pi, really? Well, let's dive right into it. At its core, pi is a special mathematical constant, the ratio of a circle's circumference to its diameter. This ratio is the same for every single circle in existence, from the smallest speck of dust to the largest celestial body. This constant ratio, my friends, is what we call pi. But let's break it down even further. Imagine you have a piece of string and a perfect circle. If you were to wrap that string around the circle once, you'd have the circumference. Now, take that same string and stretch it across the circle, passing through the center. This length is the diameter. Pi is the number of times the diameter fits into the circumference. Now, here's where things get interesting. Pi is not a whole number. It's not even a rational number, which means it can't be expressed as a simple fraction. Instead, it's an irrational number. It's approximately equal to 3.14159, but that's just the beginning. The decimal points of pi go on indefinitely without repeating. You might be thinking, that's impossible. How can a number just go on forever? Well, that's the magic of mathematics. It's a realm where infinity is not just a concept, but a reality. So we have this number pi that's both irrational and infinite. It's a mathematical marvel that continues to captivate scholars and enthusiasts alike. It's a number that's both practical, used in countless equations and calculations, and mystical, with its never-ending decimal points. And that's not even the whole story. There's so much more to pi, from its role in geometry to its appearance in statistics and physics. It's a number that transcends its mathematical origins to touch upon the very fabric of reality. And that's the beauty of pi. It's a never-ending, non-repeating decimal. It's a testament to the infinite wonders that lie within the realm of mathematics. And we're just getting started. But where do we see pi in real life? Is it just for mathematicians? Far from it. Pi is a crucial component in a wide range of fields, not just mathematics. Let's take a stroll into the practical world of pi, shall we? Imagine you're an engineer working on a construction project. The pillars, the beams, the domes all have one thing in common: geometry. And where there's geometry, there's pi. The circular structures and arcs are all designed using pi as a fundamental element. It helps in calculating areas, volumes, and surface areas, ensuring the precision we need in our structures. Now let's say you're a physicist. Physics is riddled with pi. It pops up in the most fundamental and complex equations, like those of wave mechanics, quantum mechanics, and even Einstein's field equation of general relativity. You see, pi is not just about circles. It's about oscillations, wavelengths, and fields. It's the silent partner, helping us understand the universe's physical laws. But wait, there's more. Let's dive into the realm of statistics. In the heart of statistics lies the bell curve, or the normal distribution curve, which is used to study and understand data. Guess what's in the equation of that curve? You got it, pi. It helps statisticians to predict probabilities, analyze trends, and make sense of the world's randomness. And speaking of probabilities, pi has a surprising role in probability theory too. Ever heard of Buffon's needle problem? It's a probability puzzle from the 18th century, where dropping a needle on a grid of parallel lines leads to a method for calculating pi. It's a beautiful connection between randomness and this ubiquitous constant. So you see, pi isn't just some esoteric number that mathematicians love to play with. It's a universal language, an essential tool in our understanding of the world, from the massive structures we build to the invisible laws that govern the universe. So, pi isn't just confined to the realm of theoretical mathematics. It's everywhere around us. Humans have been fascinated with finding more digits of pi, but why? The alluring mystery of pi's infinite decimal places has been a captivating journey for mathematicians and scientists throughout history. This quest, this intellectual pursuit, is about more than just numbers. It's about pushing the boundaries of human understanding, challenging our computational capabilities, and most importantly, it's about our insatiable curiosity. Let's take a step back in time. In the 3rd century BC, Archimedes of Syracuse, an ancient Greek mathematician, was one of the first to calculate pi. He did this by inscribing and circumscribing polygons around a circle and calculating their perimeters. His approximation was incredibly close to the actual value, and this method laid the groundwork for future pi calculations. Fast forward to the 20th century, and we see the advent of computers revolutionizing the hunt for pi. In 1949, the ENIAC computer calculated over 2,000 digits of pi, setting a new record. But this was just the beginning. The quest continued, with each new milestone shattering the previous one. In the 21st century, the pursuit for pi has reached astronomical proportions. As of 2023, the world record for calculating pi stands at a mind-boggling 50 trillion decimal places. This was accomplished by Google's employee Emma Haruka Iwao using cloud computing. But why do we need so many decimal places of pi? In reality, we don't. NASA's Jet Propulsion Laboratory only uses pi to the 15th decimal place for its most precise calculations. The pursuit for more decimal places of pi is not about practical application, but about the joy of exploration, and the satisfaction of achieving what was once thought impossible. The quest for pi has shaped the course of mathematical history, pushing us to develop new algorithms, build more powerful computers, and expand our understanding of the universe. It's a testament to the power of human curiosity and our thirst for knowledge. The quest for pi is a testament to human curiosity and our thirst for knowledge. Let's circle back to geometry, where pi truly shines. This mathematical marvel is deeply rooted within the fabric of geometry, especially where circles are concerned. It's the secret ingredient that makes circles tick. In essence, pi is the ratio of a circle's circumference to its diameter. This means that no matter how big or small a circle is, this ratio always stays the same. It's always pi, roughly 3.14. It's an intrinsic property of all circles, a fundamental truth that binds them together. But pi doesn't stop there. It also plays a pivotal role in calculating the area of a circle. The formula for the area of a circle is pi times the radius squared. Radius is the distance from the center of the circle to its edge. So if you know the radius of a circle, you can use pi to find its area. From a larger perspective, pi is not just about circles. It shows up in formulas dealing with waves, such as those of light and sound. It's involved in the spirals of DNA, the ripples in a pond, and the shape of rivers. It's a thread that weaves through the entire tapestry of mathematics and physics. Moreover, pi is used in various formulas beyond geometry. For instance, it's integral in calculating the volume of a sphere, the surface area of a cone, or the volume of a cylinder. In essence, pi is the language that allows us to communicate with circles and other geometric shapes. It's a key that unlocks a vast world of mathematical beauty and harmony. It's a bridge that connects the abstract world of mathematics with the tangible world of physical reality. In the world of geometry, pi is the star of the show, giving us the tools to understand the world around us. So the next time you marvel at the perfection of a circle or ponder over the complexity of a spiral, remember pi, the silent hero behind these geometric wonders.